Bismillah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Firstly, let me introduce myself. My name is Mirza Abdul Hafizh from 10TKJ and today I wanna to share to you about OSPF implementation on Cisco device. So, uh, the goal of this project is we can deploy OSPF to enable dynamic routing between lab using Cisco router. And why we use OSPF, not another routing? Because OSPF is the fast, scalable, and suitable for multi-router labs. It's standard IGP used in many networks. So after we learn this, I hope you can understand OSPF concepts and configure Cisco, verify routes, and analyze the performance of the routing. So first, we need to understand what is OSPF. So OSPF is a link state routing protocol that means each router builds a map, LSDB, meaning link state database of the network. And OSPF use Dijkstra for algorithm to compute shortest path. And OSPF has the fast convergence and hierarchical design with areas. So, after we understanding the basic of the OSPF, we need to understand what OSPF use for running or the concept is. So first, there is the OSPF area. That is the logical grouping of routes to reduce routing overhead. Area 0 is the backbone. And then there is a cost, that is the metric based on interface bandwidth. So lower cost means preferred path and manual adjustment is possible. So cost we can adjust manual, the that is can automatic too. After that we have neighbor and agency. So it means routers from neighbor relationship on shared network and exchange LSS once agent. So here we will use the simple topology. We use three router in a row, and each router has a LAN to PCs. All router we built in area 0, and we will use subnet 1.0, 1/24, 2/24, and 3/24. One is for router 1, 2 is for router 2, and 3 is for router 3. So here I will explain to you how to configure OSPF with Cisco CLI. So first we can enter the global configuration mode with enable. After that we can type configure terminal. And after that we can start OSPF process using router OSPF and we input process ID. Process ID is a number, any number, start from 1 until 250. And after that we can advertise network with command network, and we input the network. So as example, we will use first this. We have 192.168.1.0/64. So we input this into the network. And for wildcard mask, we can use, because we will enter the 64 subnet, we can use 0.0.0.215. And we can use area 0 because we will implement in area 0. and then we can adjust the interface cost. This is optional. With comment interface, if interface is interface ID. After that, we enter the comment IP OSPF cost. After that, we can enter the value. After that, we can verify and share, verify and save. After that, verify and save with show comments. After that, with memory. So this is the complete configuration example. We enable and configure terminal. We can set the host name. After that, we enter the interface into gigabyte 0/0. After that, we add the IP address and subnet mask. After that, no shutdown. So this interface is active. After that, we switch into another interface that is gigabyte 0/1. After that, we add the IP address and no shutdown. After that, we configure OSPF here. That is, we include the network that we have, that is 10.0.12.0 and 192.168.1.0 with both of these with /24 and at the area 0. After that, we end and write memory, so the configuration can be saved if the router was shut down. Okay, after that, we can verify the configuration using show IP OSPF neighbor. That is, we'll check the adjacency state with another router, and then show IP route OSPF. That is, we can view learn OSPF route. After that, we can ping 192.168.3.1. So we can try to connect to router 3, and then we can trace route to router 3. So we verifying that this packet from router 1 is going to router 3 via router 2. Okay, after this, result and analysis, connectivity. So on this topology, all LANs can reach each other via OSPF LAN route, ping and test route test pass. After that, convergence, topology change. If topology change, convergence quickly in the lab, OSPF recalculated shortest path within seconds. After that, we have troubleshooting dots, that is common issue, like one with cut mask, mismatch area ID, passive interface, or passive misconfiguration. So what we do after we configure the OSPF, so we can, here I have conclusion, that is OSPF is suitable for lab networks, reliable and fast. We can practice to build the 3-router topology and configure OSPF and one verification command. For advanced follow-up, we can introduce area types, OSPF authentication, and route summarization. Okay, I think that's enough. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.